Good morning and welcome everyone. As I
Morning,
said,
sir.
let's start the roller coaster. And this is a roller coaster ride. The last class for this what for this
Lecture number 15 or 16, sir.
yes beta
Lecture number 16, sir.
16. Oh, well corrected. Thanks for the correction. I'm very bad with numbers. Okay, 16. Lecture 16 and it's corrected. And it's a roller coaster ride. Why I'm saying the word roller coaster off and off again? Has this got something to do with the roller coaster? Okay, just have a quick recap of what we had done in the previous classes. In the previous classes, we had seen, and then I will go back. Time machine, time machine, time machine, 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 time 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 machine. Oops. Yes. I go back to this lecture, which was taken, I think, 3 or 4 classes before. And the heading was like this: motion on the inner surface of a circular track, dum 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 dum, or mass attached to a string, all in blue. And a thing was specifically mentioned. What was the thing that was mentioned here?
Not confined circular path, sir.
Not confined to circular path. That means, simple meaning of this term was, these bodies, they were free to leave the circular path, whether it is on the outer surface of a circle. We saw that this body will fall, whether it was a string attached to a bob, and it was at some point, if the speed is not that much, how much the speed should be? If it is more than root 2 GL but less than root 5 GL, tension will become zero at some point. Do we remember this? If the speed is between root 2 GL and root 5 GL, at some point it will leave the circular path. Do we remember this?
Yes, sir.
And we had seen that if it is exactly equal to root 4 GL, at some point it leaves. And we had also seen that point. Yes or no?
Yes, sir.
We had seen that at an angle of cos inverse 2 by 3, it leaves the circular track, right?
Yes, sir.
Now, I told you, this was the question that we did, or the case that we did, when the speed was root 4 GL. If you can see this, the speed was root of 4 GL, and we had seen that it leaves the circular track at an angle where theta is cos inverse 2 by 3. Now, I told you that there could be a case where things could have been different. What if I make this body somehow, and what is that somehow? We'll see that somehow confined to the circular path. So this is next bit: motion confined to a circular path. Motion confined to a circular path. Motion confined to a circular path, and this is the last heading for this chapter: motion which is confined to a circular path. Now, what's the difference between motion which is not confined to a circular path? The body can leave the motion.
Cannot leave the circular path.
It cannot leave the circular path. Now, how can I make the body not leave the circular path? Let us do it by example. If, for example, a roller coaster, that's why I use the word roller coaster. Roller coaster goes up, roller coaster goes down. Now, when it is at the highest point, it is moving on the outer surface of the track. Yes or no?
Sir.
Now, roller coaster doesn't fly off. Roller coaster remains with that circular track. Yes or no?
Yes, sir.
Why doesn't it fly off? Because it is confined to the circular path. So it has a rail. If this is the rail of the roller coaster is put like this. So it cannot go anywhere. It has to what? Keep on moving on that circular track. We understand this?
Yes, sir.
That is motion confined to a circular path. if it was inner surface, I put the roller coaster like this so that it never leaves the circular path. Now, if the roller coaster is like this, it can never leave the circular path, whether it's on the outer rail or it's on the inner rail. So I have made it confined to a circular path. Yes or no? There are other examples of making the motion confined to a circular path. Now, in place of a string, if I attach something else to this bob, I can also make this motion confined to a circular path. What should I use in place of a string to make this motion confined to a circular path? Anyone? If I use a string, it is free to move. It is free to leave the circular path. But I don't want it to leave the circular path. I want it to be confined to the circular path. What should I use in place of a string? The problem with a string is, string can only pull. It cannot push. That is the problem. What can I use in place of a string that can also pull and also push? If I can find a body which can pull as well as push, I can replace it by that body and it becomes a motion confined to a circular path. So what do I use?
Spring, sir.
Yes, I can use a spring or I can use a rod. Do we understand this? Rod, solid rod.
Sir.
And I attach this bob to this rod, bob of mass m to this rod. Now, if I attach it to this rod, it cannot leave. It cannot leave the rod. Yes or no?
Yes, sir.
So this becomes a case of motion which is
Confined to circular path.
motion which is confined to a circular path. I'll give you more examples. All of girls normally wear rings, right? Rings, you understand rings? I don't have a ring here. Or boys wear this kada in their hands. Now, if I have a small bead inside that kada, bead, you understand bead? Now that bead moves inside that kada, inside that ring. That is also motion which is
Confined to circular path, sir.
confined to a circular path. I can cite you more examples. And here are the more examples coming on your screen right away. Where is that? It's here. Right away, right now. This is a rod. Oops. This is a rod. And I have a bob attached to a rod. This is a motion which is confined to a circular path. All of us understand this? Can I have some raise hand that we understand this? Everyone, boys, girls? Okay. Then the second case or the other case is this. A bead attached to a ring and rotated. This is the kada or the ring that girls and boys wear. And you have this small bead. Now this bead cannot leave the circular track. Do we understand this? Can I have some raise hand that we understand this? All of you, I'm not getting all the hands up. I can see I'm not getting the hands up. Yes, we got this. Now there is one more example. It's very simple to understand that somehow I'll have to move. Somehow I'll have to make the body not to leave the circular track. This is case number 3. I have an inner track and I have an outer track. And I have a body in between the inner track and the outer track. Now it cannot leave the circular track. Yes or no? Yes or no? All these are examples of motion attached or motion confined to a circular track. One more question that I have seen in one of the JEEs has come. I am a aeroplane pilot, a fighter jet pilot. Now, A fighter jet pilot can do all sorts of stunts. They can do a stunt where they go up, 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 and they take a complete loop and come down. Have you seen that stunt somewhere? Airplane jet pilot doing these stunts
Yes, sir.
where they make the entire plane go in a loop. You have seen that? Yes or no?
Yes, sir.
Now, when they go in a loop, the plane is like this, and then they go up in a loop. Ooh, the plane becomes ulta, upside down. Yes or no?
Sir.
Now, if I am this fighter pilot, I am wearing my seat belt attached to the seat. There are two cases possible. I am wearing my seat belt and I am not wearing my seat belt. I am wearing my seat belt and I am not wearing my seat belt. Can you tell me which case is which? Wearing my seat belt, what is the case? Not wearing my seat belt, what is the case? Case means motion confined to circular path. Case means motion not confined to circular path. So which case is which?
Wearing seatbelt is confined to circular path.
And
Not wearing belt is not circular.
that is very correct. If I wear my seat belt, I am not going to leave this plane. I'll have to move with the plane. Motion is confined to the circular path.
Not with plane.
Yes, beta? Yes, that is correct. So when I'm wearing my seat belt and I'm performing this stunt, this motion is motion confined to a circular path. If the plane moves upside down, I'll also move upside down. But if I'm not wearing my seat belt, this is motion not confined to a circular path. Well, I have to be careful. What should be my speed at the lowest point so that I don't fall at the top? Do we understand this? Understand the difference between motion confined and motion not confined? Can I have some reason that you understand this?
Yes, sir.
Okay. Now let us jump back and go to the case where now the motion is definitely confined to a circular path. Now we will see the various cases of motion which is confined to the circular path, and we will try to understand what is the difference between the two cases. So I will start with case number 1, and case number 1 is, let me call this point as A. Let me call this as VA. Case number 1 is VA is less than root 2 GL. What will happen in this case? If VA is root 2 GL, will anything change here or will everything remain same as the previous case? Will anything change or will everything remain same? Any idea? Everything remains same. What do I mean by everything remaining same? What do I mean by everything remaining same? That a motion will be confined, or if I call this point as A, if I call this point as B, and if I call this point as C, what will happen if the speed at point A is less than 2 GL? What will happen? What will happen if my speed is less than root 2 GL? No one knows?
Body does not reach point B, sir.
Body does not reach point B. What else? Body does not reach point B. Somewhere between A and B, what will happen?
Become zero between A and B, sir.
Speed will become 0 between A and B. Yes. And tension never becomes 0. Yes or no? We understand this?
Yes,
Can I have
sir.
some reason that we understand this? This is also a revision of what we have done for motion not confined to a circular path. All the boys, can I have some raised hands, and girls? Okay. Case number 2. Now, speed at point A is exactly equal to root 2 GL. What will happen here? Is it same or is it different?
Body reaches point B, sir.
Body reaches point B. B, what will happen at point B? What will happen at point B? Don't remember what will happen at point B? At point B, both what? Both tension and velocity will become zero. Do we understand this? VA is greater than root 2 GL. If I go into this case, VA is greater than root 2 GL. Now, I'll have to find out, let me not take this case. I'll have to find out the condition for looping. What is the condition of looping? The condition of looping is that it reaches point C. Now, in the previous case, the condition of looping was tension should not become equal to 0. But here, the rod can pull as well as the rod can also push. So the condition of looping here, condition of looping, do you understand the meaning of term looping?
Yes, sir.
Condition of looping, that is to complete circular path is that speed v never becomes 0. Never becomes 0. Tension T can become 0 or it can also become negative. Now, what do I mean by negative tension? Anyone? What do I mean by negative tension? What do I mean by negative tension? So, if I have a rod like this, I hope everyone can see this, yes or no? If I have a
Sir.
rod like this and a body of mass m is attached to this rod, now this rod can pull, yes or no? When it pulls, the pulling tension T is what we call it as positive tension. Do we understand this?
Yes, sir.
The rod is pulling you, you call it positive. Then what do you call it as negative?
Pulling downward.
Pulling downwards. And this pulling downwards is not positive. If let us say that the rod, the center is here, and the rod is like this, and the bob is here. So I'm talking about a point which is above your midpoint B. It is there at some point, and instead of rod pulling this mass, the rod is pushing this mass. T, or normal reaction N, if you want to call it. If you want to call the pulling force as T, if you want to call the pulling force as T, you can call the pushing force as N. N also stands for negative. Are you getting my point?
Yeah.
So if the rod is pushing, we can call it as pushing tension or normal reaction. You can call it as negative. So that is what I mean by the rod can pull as well as the rod can push. So the condition of looping now becomes the rod can pull as well as the rod can push. So I don't worry about tension becoming zero or negative or pulling or pushing. I am only concerned by one thing. What is that concern that I have? That the body must reach its highest point. So what is the condition of looping? Now, the condition of looping is changed, and the condition of looping now becomes velocity at point C should be greater than, if it is greater than, no problem, or equal to 0. The condition has changed. Do we understand this? Do we understand this? Everyone, can I have some raised hand that we understand this? The condition of looping has been changed to VC becoming greater than or equal to 0. Equal to 0 is the condition when it just reaches. Greater than 0 is the condition when it will cross the point C. Now I'll give you a question that you have to answer in form of a case. So I have a question for you. Question number 1 in this case. If velocity at if the body completes the loop, or I should say just completes the loop, or just reaches point, which point?
Point C.
Well done. Just reaches point C. Find out, and you have to do it with your own hands. The length of the rod is L, that is given to you. The mass of the block is M, that is given to you. Acceleration due to gravity is G, that is given to you. And you are also given that the body is just completing the loop. It is attached to a rod. Motion is confined to a circular path. Find all the things. What are all the things? VA, VB, VC, TA, TB, and TC. Can you do that for me, everyone? Will you try this? If you can do this on your own, you will never forget it. Else, I'm always there to help you out. I will draw a diagram to assist you. I will draw a diagram to assist you. So basically what I'm looking for is the case. I have this, and this is now a rod. Remember, it's a rod, not a string. It's a rod. The length of this rod is given as L. I have a mass attached to this rod M. This is my point A. This is my point B. And this is my point C. You have to find out VA, VB, and VC. The condition is given that it just reaches point C. You have to find out TA. You have to find out TB. And you have to find out TC. I'm not drawing TC for one simple reason. That reason you will understand once you solve the question. 1 minute, minute, 2 minutes. Let's begin the answer. What is the condition of looping? So velocity at point A should be just equal to how much?
Root GL, sir.
That would be equal to 0, my dear friend. We have just discussed this. Yes or no? It's not root over GL. Who told you it's root over GL? This is the case of motion confined to a circular path. So the only criteria I'll have to see is the velocity at point C must just become 0. Do we understand this?
Yes, sir.
Velocity at point C must become 0. As soon as I know the velocity at point C, as soon as I know the velocity at point C, as soon as I know the velocity at point C, you can tell me, I had given you shortcuts in the last class. You can tell me the speed at point B and the speed at point A. Fatafat, give me the answers now. Fatafat, give me the answers now. I've already told you all the short tricks. How did I get to all those short tricks? I just utilize the equation that I have given you. What is the speed at point B? You know the speed at point C. You know the speed at any other point, any point. You should be able to calculate the speed at the other points. Can I have the answers? Yes, beta. Tell me.
3GL, sir.
Which point, beta? B or A?
Yes, sir.
Velocity at point B is root 3GL.
Yes, sir.
No, it is not. You have not gone through the last class, it seems. Anyone else? Girls, you know the speed at point C. If you can't tell me the speed at point B, that means whatever we have done in the previous class all goes down the drain. And it's not a good feeling to see the hard work that I had put or you have putting go down the drain. Anyways, I can't waste more time, and the answer is root 2GL will be the velocity at point B, and root 4GL would be the velocity at point A. Do we understand this now? At least by seeing it. Do you remember that shortcut I told you? Do we remember this? Yes or no? No one remembers it. How did I get this?
Remember, sir.
Was it so difficult to remember? Well, if
Yes,
it is
sir.
so, it was difficult to remember.
Yes, sir.
Yes. God help you. May God help you. Anyways, I'll pray for you. But right now, can you now tell me the tension at point A? The velocity at point A is root 4GL. That means the condition of looping becomes the velocity at the lowest point is root over 4GL. That is the condition of looping here. Can you now tell me from the previous class? I know that you don't remember anything from the previous class, but still, I can always hope that memory will come back. What is the tension at point A if the velocity at point A is root 4GL? Anyone knows it?
5 mg, sir.
How much?
5 mg.
Okay, so welcome back, memory. I am back, and that's good news. Tension at point A becomes 5 mg. Can you now tell me what is tension at point B? Everything is coming from the equation, but I had given you shortcuts. Everyone is looking back, and that's the worst habit in the entire universe, to look back. Up. If you're looking back, that means whatever we had done in the past is all gone down the drain, flushed. And there's no point of putting your hands in the flush and taking something out because that's dirty. Sad. Sad state of affairs. Tension at point B. If you don't remember it, I cannot help you. It has to be
4
equal
mg,
to
sir.
how much?
4 mg.
Even you put your hands in the flush, you still not able to take out whatever is clogging your flush. It is 2 mg, my dear friends. 2 mg, my dear friends. It's 2 mg, my dear friends. You don't remember it? Wah! Go back. Go back and flush your sinks and toilets. It's very bad. I have no words to describe. I told you the shortcuts and all. Still, see, the entire good work that I did in this class, the class is right in front of you, has gone down the flush. It's being flushed, miserably flushed, miserably flushed. Anyways, anyways, anyways. Let us come back to today's class, and I hope for better time ahead. I hope you don't have to flush things out or clean the flush. Velocity at point C is 0. Now, what does it give me the tension at point C? Now, there are two ways of understanding this. As I told you, you have to look at the relation between the two. This is 4, this is 2, and this is 0. So you find the relation between these two. Again, I am going back. This is 5, this is 2. So you now know what is the value here. What is the value here?
Minus mg, sir.
It's minus mg. But try to understand what does minus mg mean and try to make sense of minus mg. Mg is always downwards. If I draw the free body diagram here, mg is always downwards. If I draw the free body here diagram here, mg is always downwards. If I draw the free body diagram here, mg is always downwards. Yes or no?
Yes, sir.
At point A and at point B, the rod was pulling. Yes or no?
Yes,
but here velocity has become 0. That means the centripetal force should become, the velocity is 0. What about centripetal force? Centripetal force is mv square by L or R. What about the centripetal force? What is the centripetal force if the velocity is 0? Centripetal force should also become
0, sir.
yes or no? Now, if I look at this diagram, this mg is downwards, just trying to pull it downwards. So there is a net force in the downward direction. There is a net force in the downward direction, but by logic, I'm getting that the net force, centripetal force must be 0. So there must be something. There must be something. There must be something. There must be something that is equating this weight. Who is going to equate this weight now? Who is going to equate this weight now? There must be something in the upward direction.
Normal, sir.
And that is the tension T or normal reaction N on this block. Now, as you can see at point C, what is happening? The rod is not pulling it anymore. It is doing what? It is pushing it. Am I clear with what I am saying? Am I clear? It is now pushing it. Got my point?
Sir.
Instead of writing it as mg, I have drawn the direction. Instead of writing it as minus mg, I don't write negatives in my life. I will write it as mg, and I will write it as in the upward direction. It is a pushing force. This yellow is a pushing force. Do we understand this? This is a pushing force, whereas all these two which are in green, all these two which are in green, they are all what? They are
Pulling
all
force.
pulling forces. Do we understand the difference between the pulling force and the pushing force? Yes or no?
Yes, sir.
Well done, bacha. Well done. Rod is pulling at some point, rod is pushing at some point. Yes or no? Do we all understand this? Can I have some raised hands? All hands are clear. We have cleaned our hands after pushing it in the flush. Yes or no? And we have sanitized our hands as well. I have also put hands in the flush. Once upon a time, a ball got stuck I had to take it out. So we have to put our hand in the flush. If you become mechanical engineer, so your hands are always in the flush. So don't worry. Flush does not mean something bad. Flush means you are cleaning up. And as Mahatma Gandhi, cleanliness is next to godliness. If you keep yourself clean, you are God. So we are cleaning stuff. And now we have understood that in this particular case, root 4GL is the velocity I had given at the lowest point, and I had seen at the highest point. Instead of rod pulling, the rod has started to push. Up till point B, the rod was pulling, but at point C, the rod is pushing. The force has changed from pulling to pushing. Somewhere it would have happened that the force is zero in the rod. Do we understand this?
Sir.
Because pulling to pushing does not become instantaneously. Right now I'm pulling and then pushing. No. Even if I'm doing that, pulling and then pushing, at some point the force is zero. Yes or no?
Yeah.
That is the next question, my dear friends. At which point is the force zero? And I will draw that point for you. That point is C. Oh, sorry, D. At this point D, which I'll draw in which color is left? Oh, I've used all the colors. Pink, my favorite color. Pink. At this point D, the force in the rod is zero. Remember, force in the rod, not centripetal force. No, not centripetal force. Centripetal force is zero at the highest point, which I have already right in pink. At this point, the force in the rod, or if let me call it as tension, T in the rod is zero. Below this, it is negative because I call pulling as negative. Above it, it is positive because I call pushing as positive. Oh, ulta, sorry. Below it, it is pulling, tension, I call it positive. Above it, it is pushing, I call it negative, whatever. At this point, there is no force in the rod, my dear friends. Can you tell me the location of this point? By location, what I mean is this angle theta. Can you tell me the value of this angle theta? Oops. Also, at this point, this gentleman would be having some velocity Vd. Can you now tell me the value of this theta and this Vd? And you already know it, but again, you will have to push your hands in the flush. Go back in past because I know that you don't remember it. कोई बात नहीं, you can go back in the past and see and tell me at which point is the velocity zero. And I'm saying it in a good sense. Though I don't appreciate anyone going in the past, because if you go in the past, I mean, you can change things and your future may become very difficult. So, for example, it's known as the grandfather paradox, and that is one of the paradoxes that prevents your traveling in the past. You go back in the past and you kill your own father or you kill your own grandfather, how will you born? If you are not born, how will you go back and how will you kill? So that's a paradox. It's known as the grandfather paradox. So don't change anything when you go back in the past. Just look, observe the past, and come back. Don't do anything. Okay, so I hope everyone has gone back in the past, seen what was happening in the past, and tell me at which point theta this velocity becomes zero. Oh, no. The tension becomes zero. Anyone with an answer? No one has an answer? At point D, tension T becomes zero. The force in the rod is zero, my dear friends. Where is this point located? What is the velocity at point D? What is the value of this angle theta? You all know it. Who is going to tell me the answer? Who is going to get his hands dirty? The dirty hands will be my hands because I am a mechanical, I am an engineer, I have dirty in my hand, I put my hands. I can't even tell you where all to clean things up. Because in a machine, wherever you put your hands, dirt only comes out. There's a thing known as a build separator, it's all full of dirt, and you have to clean it out. Under root 2 by 3 GL. What is that? Velocity or point? Yes, that is my correct answer, my dear friend. Oops, I wrong used the wrong color in excitement. I must take this off.
Theta equals to 2 by 3.
Yes, that is correct. So now you remember that very important point where your cos of this angle theta happens to be 2 by 3. This is exactly same as what happened in the previous case. In the previous case, that means the previous case where the motion was not confined to the circular path. In that case, what happened? Tension became zero and this gentleman was free and he was following the path of a projectile. But now this gentleman is not free. So even if he wants to go, he cannot go because the rod will say, "Oh, right now I'm pushing now till now I was pulling, now I'll try to push you out. Don't worry, you're not leaving this path." No, 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 no. Similar to what you are here, you are confined to this hostel. You cannot leave this hostel. So you are also confined to a circular path of the hostel. Whatever happens, you have to follow the rules of the hostel. You are also confined. So at cos theta is 2 by 3. So when you are 2 by 3 years old in the hostel, the tension might become zero. Instead of hostel pulling you, the hostel will try to push you out. Go back. The fees is submitted. Now you go back. But then you will say, no, 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 we'll keep moving in the circular path because at the top of the circular path, I see IIT at the top of this path. And even if I reach with velocity zero, good enough. I've reached my IIT or NEET or JEE, whatever. So I don't want, I always pulling. You can also push me sometimes. I'm confined to the circular path and I'll reach the topmost point. The condition is that I must reach it. I must be confined to the circular path. My velocity would be zero. And at this point, my velocity, I still have velocity. Tension has become zero, but the velocity is still there. And the velocity at point D is 2 by 3 GL. It is absolutely correct. So do we understand what we have understood in this particular case where the motion is not confined to a circular path, and what is the difference? Now, if the velocity is more than root 4 GL, for example, root 5 GL, the same thing happens what happened in the previous case. Root 6 GL, same thing happens, nothing happens. The only particular case is it does not need tension to take it up. It is attached to the rod, it will go up anyway. It only needs to have that much of velocity. And that is what we are trying to do here in your class. Either we pull your socks or we push you out. We're just trying to give you that much velocity that you reach the highest point, and that refers to your IIT. So this highest point will be named as IIT now, or your aims or whatever. For medical students, I'll call it aims. For JEE batch, I'll call this point as IIT, the point where you reach no matter how. Now, if you reach this point with non-confined to a circular path, you will be reaching there with a good rank. So more the velocity at the lowest point, the more velocity you will have at the highest point and you will reach there. So try to get this velocity. Now, greater this velocity, you will reach your IITs with more velocity. Am I clear with this point? Yes or no?
Yes, sir.
I hope you will remember this and it will not go down the drain. When it goes down the drain, you have to clean it. So I don't have a problem. I put my hands, I dirtied my hands a lot of times in the drain. I've cleared a lot of drains, don't worry. And I'm very proud of what I've done as an engineer. That's my task, so I'll do it. There's nothing wrong in dirtying your hands, because if you don't dirty your hands, you will never learn anything new in your life. That takes us to this particular case. So case number 2, when it is a rod, that is what we discuss. What is the condition of looping? What is the condition of looping? The velocity at the lowest point must be equal to what? Root 4 GL. Do we understand this?
Sir.
Similarly, for this bead, the velocity at the lowest point must be equal to root over 4 GL. Now, how this tension, this pulling and pushing will come? How will this pulling and pushing come in this bead? I'll try to make you understand with a simple diagram. For example, when the bead is at the lower point, I'll draw the bead by red color. When the bead is at the lower point, the bead would be like this. This end would be touching the circle. Do we understand this?
Yes, sir.
If I call this upper end as A and the lower end as B, upper end would be touching the ring. Do you understand this? It will be hanging like this. It will be hanging like this. This is my ring. This is my bead. It will hang like this. Do you understand this?
Yes, sir.
Okay. But when it reaches the highest point, my dear friends, the bead would be hanging in a different fashion. Can you tell me what fashion the bead will be hanging? It would be hanging like this. But the only difference is when it goes from here to here, it changes, right? Ulta becomes Sida and Sida becomes Ulta. Yes or no?
Yes, sir.
Top becomes bottom and bottom becomes top. Yes or no?
Yes.
So now you will have B point on the top and A point on the bottom. As you can now see, it is touching point B and it is not touching point A. Do we understand the logic of pulling and pushing here?
Yes, sir.
So at some point, the bead would not be touching the ring. At some point, the bead would be free. It will not be touching the ring. What will be that point? The velocity at the lowest point I have given is root over 4gl. At some point, the bead would not be touching the ring. What will be that point? Where will that point occur? Not the upper part, not the lower part. Nothing will be there. Only the bead will be hanging in air. What point? When the angle becomes when the angle becomes when theta becomes cos inverse 2 by 3, it will be hanging in air. Do you understand this? It will not touch the lower part, it will not touch the upper part. Yes or no?
Yes, sir.
Similarly, for this case, now can you tell me what happens in this case? At the lowest point, what what is touching it, and at the highest point, what is touching it? At the lowest point, it will be pushed up by the outer rail. Yes or no? When the bead is at this lowest point, it will be pushed up by the outer rail. Yes or no? But when it is at the highest point, it will be pushed up by the lower rail. Do you understand this?
Yes, sir.
So that is how pushing and pulling happens in this case. At the lowest point, lower track pushes it up. At the highest point, lower track pushes it up. Do we understand this? So at some point in time, this will be hanging in air. At what point will it be hanging in air? When the angle becomes cos theta becomes 2 by 3. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. If you have any problems, you can ask me. So at some point it is pushing, at some point it is pulling. In terms of string, pulling, pushing, and I have shown you the same thing that happens for a bead in a ring or for a ring in between two rings. Now, if you remember, not for NEET students but for JEE students, we had done a case where the velocity at the lowest point was root 3 GL. Yes or no?
Yes, sir.
We had done a case where velocity was root 3 GL and we had found out the point where the tension becomes zero. Yes or no? Now again, you will not remember that point. I know that. Any idea? Any guess what that point is? Where the tension becomes zero in this case? I told you that point, right?
Theta equals to 1 by 3.
Cause do you see my screen, bacha, or not? You see my screen, yes or no?
Yes, sir.
Okay, so at what point that the tension becomes zero? The tension becomes zero at the point where cos theta is 1 by 3. So please remember this. Now, even if it is a rod, this is the same point where the tension becomes zero. After this point, what will happen? After this point, what will happen? If it is a string, if it is a string, it will follow a trajectory. It will follow a projectile path. If it is a rod, it will keep on still going upwards. Yes or no?
Yes, sir.
Will it reach the highest point even? If it is a rod, it will still not reach the highest point. It will stop somewhere in between. Do we understand this?
Yes, sir.
Okay, so this was the case, and I think I have completed everything that I was supposed to complete and supposed to let you know. But you might be wondering that we have done the entire circular dynamics, but still not seen a force that you might have heard before, and that is the centrifugal force. Have you heard this name before, centrifugal force?
Yes, sir. It is a pseudo force.
Yes, and you would be wondering, sir, we have done the entire circular dynamics. You have not taught us what is centrifugal force, because I don't want to tell you about that. Because there is no reason that I should tell you centrifugal force when you actually don't need it. Now, the centrifugal force is basically a pseudo force. Now, I only use this centrifugal force when I make the equation of this body. Right now, whenever I'm making the equation of this body, I'm making the equation from where? If I'm making the equation from ground, what I see is the centripetal force. Do you understand this?
Yes, sir.
So all the equations that we have made for this block, for anything that was moving in a circular path, was from ground. And that is the best possible way of doing any question. Do it from ground for this. You will not require to make the equation from the rotating frame, because that is a concept which gets very confusing at times. Now, if I for some reason would want to make this equation from an accelerated frame, then only I will use the term centrifugal force. Do we understand this?
Yes, sir.
Now, this frame of reference is a very complicated frame, and what I have to do is I will have to rotate about the axis with angular velocity omega. So I'll have to rotate like this. If I have to see this block from a accelerating frame, I will have to rotate like this. Why would I want to rotate like this here? Life is very difficult, वैसे ही. Why should I make it more difficult? I will not make it more difficult. I will always need the equation from where? Which frame?
Later frame, sir.
From the ground frame, and I will always use centripetal force or centripetal acceleration. I will never think about what? I never think about centrifugal force. So this is absolutely not required to solve any problem. It would be required only to solve very, very complicated problems, which we'll do, but not now. We'll do it at a proper and appropriate time. For one particular problem, if I could remember, that could be done by easily by centrifugal force and not by centripetal force so easily. So if I come across that problem, then only I'll do or I'll discuss centrifugal force. L centrifugal force is not required at all. Do we understand this? So we'll never use the term centrifugal. I don't want you to confuse, because sometimes you say centrifugal, sometimes you say centripetal. What is this? I get confused. I'll not confuse you. So I'll not tell you anything about centrifugal force. Whereas we are so confused. What we do in the last class, we don't have to remember, and again we have to put our hands down the drain. So why to confuse life? I'll just take this out of your course. That is not there in your course at all. No centrifugal term. You have never heard about this. You only know centripetal. Is that okay? Clear?
Yeah.
That's it. That's it from my end. We are done with this chapter. I have told you everything that you needed to know. Probably more than that. And with this information, you should be able to solve any question that comes in a JEE, JEE Mains, JEE Advanced, or even in Olympiads. Olympiads, probably you might need the centrifugal force because there might be a question which requires this. Anyways, that's it from my end. I hope you enjoyed this class, and I hope that you will reach at the top of the circular path that is into your IIT. I sincerely wish this. I'll see you very soon. Till that time, take care. If you have any doubts, I'm always there, available. Right? I'm right there in the group. You can ping me anytime that you feel like. Take care. Prepare for the board exam. Also keep on revising the course. I know that you are under the stress of your board exam. That is the reason why you have not read the previous class. Anyways, doesn't matter. The class is there with you. The recordings are there with you. The course material is there with you. I am there, so you don't have to worry. Chill and live your life. Stay happy. Stay healthy. Take care. Bye bye.